We start with Simon Fischer from Chef Software, and he will talk about Habitat, which is an open source project from Chef Software to basically automate your deploying of apps, if I'm correct. So I'll give a warm welcome to Simon.
Thank you. Thank you. My name's Simon Fischer. I'm a solutions architect with Chef Software. I'm English, and some of you are German, so I appreciate you letting me talk in English to you, because my German is terrible. So I'm going to talk to you today about Habitat. I'm also going to tell you a story about DevOps, and I'm first going to talk to you a bit about my personal life. So back in 2006, I was diagnosed as being diabetic, and it's the type of diabetes which means that you have to take drugs all the time. So you have to inject yourself with insulin, because insulin is a hormone which allows your body to transport sugar from your blood to your muscles, so you basically don't die. So I was diagnosed with that back in 2006, and it's quite a big thing. And one of the good things that happens in the UK, and I think it happens in Germany too, is you get invited to a training course. You know, we all work in IT, we all go on training courses all the time, but this is a training course on how to survive, basically, how to manage this condition called diabetes. And it's called DAFNE, and DAFNE stands for Dose Adjustment for Normal Eating. And it's essentially a 5-day course where you get in a room full of other diabetic people, about 10 to 12 of them, and you get to share experiences with them. Some of them had the condition for 20 years, some have had the condition for a few weeks, like I had. So it's a good range of topics, and you're also with diabetic nurses who teach you how to manage your condition effectively. And there's a whole lot of things to go into, and you know, I can talk to you at length about it, because now, 10 years later, it's kind of second nature to me. But one of the great things about this course was being in a room with other people with this condition I could talk to and share experiences with. Just as we do here today, you know, these community events, it's important to talk to people who do similar things to us and learn from them. So these events are great, and that thing was great too. And one of the most interesting parts of it was every day we had to write down what our readings were, because you measure your blood glucose and you have to read it, and then you look at trends. So you look at reports and charts and stuff which show you how you're doing against how a normal non-diabetic person should be doing. And you're in this room and you put your readings up on a projector, right? And all the diabetics in the room get to look at it and go, you could do better there, or this is where you're going wrong, and that kind of thing. And it's a great opportunity to learn from other people. The problem is that's just for 1 week. So then you go home and you're still diabetic, and these other people are still diabetic, but then you don't see them, you don't talk to them. And this was back in, as I say, back in 2006. So Facebook was just starting, social networks were just starting to emerge, but they weren't mainstream, so people didn't all use them. So I said to myself, well, what can we do about this? So I thought, I did computer science at university, I've done some programming, let's put those skills to test. So I became a developer in my spare time, and developed a website. And the website was aimed at allowing people with this condition to talk to each other, to carry on the social networking side of it afterwards, and share their readings, and basically collaborate and make sure that people didn't feel alone. Which was really good, but I was a developer, right? So I developed it and didn't know where to put it. So this is a DevOps story, right? So first of all, as a developer, even back then, my friend was Google. So I went back to Google and said, how do I deploy this Ruby on Rails application which I've built? Googled Rails Shared Hosting UK. So I found a shared hosting provider. It was a small application with a potentially small user base. So I found this shared server. So basically you take your app, you throw it at this server, and the hosting provider figures it out and does it yourself. Awesome, I thought. And I don't know if anyone here has done any Ruby on Rails development, but it has gem dependencies, and some gems need native extensions, so they need root access to the operating system to be able to build these gems. And on a shared host, where other people are deploying their applications to, they didn't want to give me root access. So I came up with things like this, permission denied, and I failed to be able to build my gems and dependencies for my application. I was a sad panda. So I had to come up with another solution. So again, I still had my dev hat on, wasn't really too bothered about this ops thing. So I went back to Google, and looked for cheap virtual private servers. I found a VPS provider called Linode, who are pretty good. Had good reviews because I didn't really know what I was looking for, and AWS and Azure weren't a thing then. I also Googled, how to deploy a Ruby on Rails application with a production level stack. So I found a guide which talked me through all the Linux type commands I had to type on the operating system to get my app from being just a standalone app in development to production where people could use it with a database and that kind of thing. And this is the stack I ended up with. Ruby on Rails, Nginx, Ubuntu, MySQL, and Unicorn. So it was up and running, which is really good. And this was probably about 2008 by the time I actually got round to developing this app. Fast forward a few years, I started working for Chef. Now, Chef is well known for its infrastructure automation, configuration management capability. And I was still running this Ubuntu server I'd created way back then, Ubuntu 10, which was well out of date, well out of support. So I looked to Chef to help me out with that. I needed to migrate server. And hands up anyone who's used Chef, who recognizes Chef code. There should be more of you who put your hands up, so come and speak to us later. But if you've written Chef code, and even if not, if you're a coder, right, you'll see this is Ruby, and this Chef code says include recipe, so it's going to utilize some other recipe someone else has created to install Nginx. So it installs Nginx for me with this line of code, and then fills in a configuration template. And I think that's pretty beautiful, right? Chef code makes it easy to define your infrastructure and repeat it and automate it and all that stuff, which is great for infrastructure. But then I came to deploy my application with Chef, and it looked a bit like this, which is very, very messy. Very, very messy code, hard to create, hard to debug, hard to test, and not really the sweet spot for where Chef works, right? And again, I was a bit of a sad panda. So then around the same time, this thing called Habitat came out. The Chef team, engineering team, created this answer to really my problem, which is how do we capture dependencies and how do we make the deployment process for applications easier, bearing in mind we are traditionally an infrastructure automation provider. So they created this thing called Habitat. And the aim is to allow you to package applications, whatever the type of application, in a traditional package and then run it anywhere, right? In your data center, on the cloud, in a container. It's meant to be a repeatable process, which will free developers from having to worry about the underlying infrastructure of where their application has to go, which is what the exact problem I faced. So it came at the right time. So what is it? I see this as two layers, really. There's the packaging or the development time for applications, and then there's the running of applications as well. And it looks after both. So you start off with an application, which could be something which is built or source code. It doesn't really matter. And then with this application, you define a plan. Now, a plan at the most basic level is just a shell script. I'm going to show you some bash. It could be PowerShell, something like that. Shell script, which defines a lot of stuff. It defines the metadata associated with the application, and it defines the way that application is built and packaged, so the building and compilation process. And I'm going to show you a Ruby application. If you know Ruby, you'll know it's interpreted. It's not compiled. But if it was a Java application, say, or something which needed compilation, you could put those steps in there as well. And once you've defined this plan, there's a whole load of other things which are part of the plan and part of the process, and I'll show you those as well. You end up with an artifact, a built artifact. And this theoretically is runnable anywhere which you can execute the Habitat command line, we can run. So, containers, bare metal, inside the cloud, outside the cloud, all over the place. And artifacts eventually make their way into a depot, which is a built artifact repository, where then you can deploy stuff from. And once these applications are inside the depot, you can take the artifacts and, as I said, run them everywhere. Now, applications are great. Standalone applications are great, but typically they are part of a broader ecosystem of things like databases, load balancers, other applications, other services, stuff like that. So with Habitat, what we can do is create what we call a ring. And a ring is basically each Habitat application has a supervisor, which is a small runtime layer packaged inside the Habitat package, which controls the life cycle of that package. But it also communicates with other packages too. So if, for example, one package disappears from this ring, from this topology, the supervisor will then spread information throughout the ring. So it's kind of like rumor spreading, right? I whisper to someone else who whispers to someone else. And that's how information is propagated throughout this ring, as opposed to some other top-down orchestrator sending instructions at it. There's a whole raft of benefits associated with that, which I can talk at length about, but I want to get to showing it to you. And these supervisors can handle things like failover. They can handle things like configuration. So if you need to update a configuration file within your package, within your application, you just send the configuration changes to the supervisor, one of the supervisors, and those configuration changes are automatically handled, which is really, really powerful. You can also define topologies. So for example, a leader topology where you have one package, which is the leader, and delegates stuff to other followers. Initializer, failover, standalone. So there's a load of different topologies. And the great thing about this being an open source project, which keeps disappearing from the screen for an unknown reason, is that it's open source, right? So you can contribute new topologies, new update strategies, and even contribute to the core Habitat binary itself. It's written in a language called Rust. So, conscious of time, I'd like to show you some stuff. So here is my actual application and my approach to building my application with Habitat. It all starts off with a plan. Let's make this big. It starts off with a plan. So as I said earlier, a plan, and by the way, this code is available on GitHub as well under Simfish85, so if you want to go and have a look at it and play with it and learn, then it's totally fine as well when it comes back. So a plan is a shell script, right? It has a load of metadata associated with it, which has things like who am I, who's the package maintainer, what's the package version, what's the name of the package, an SHA digest for the application. And for my example, it's just sitting on S3, waiting to be downloaded. It's just the raw application source code just as a zip file. Typically, it'd probably come from a source control system, but as this is a demo, it's just in a zip file. We also, which I didn't talk about, but was really beneficial to me, we also package all of the application's dependencies with it. So one of the things I ran into when I tried to take my application and run it on a different version of Linux is missing dependencies. So Ruby depends on things like libxml2, compilers, glibc, that kind of thing. And oftentimes those are missing from the operating system when you instantiate a new image, right? So what we need to be able to do is package all of the application's dependencies, including those low-level operating system libraries with the application, so we can guarantee that it will run on any environment. So we have dependencies, runtime dependencies. We also have build time dependencies too. Bunch of other things like this says that this package is going to export talk over port 3000, which is the standard Rails port. And then we have a bunch of configuration functions, right? So this says do prepare. And essentially we can put whatever we want in here, which does the preparation for building of our application. Do build. We're doing some exports. Now in the, in the Ruby on Rails world, it's not built. It's an interpreted language, right? So we're just doing some configuration stuff. And then we're running this bundle command. And if you've ever done Ruby on Rails development, you'll know about bundler. If you're a Chef user, you should know about bundler too. And it's a way of grabbing all of the Ruby gem dependencies and making sure that, again, our application has that thing. So we're installing our application. And we do some other bits and pieces around configuration, exporting configuration, that kind of thing. And that's the basic plan. So when this plan is built by Habitat, which I'll do in just a second, it grabs the artifact, it grabs all the dependencies, bundles them together nicely. But there's also runtime stuff associated with this as well, as I said. So we have these things we call hooks. If we take a look at the initialization hook, so this is the first time the application is run, it runs this initialization hook. And one of the key things is it links the database.yaml file. Database.yaml is a Ruby on Rails configuration thing, which defines where your database is, your database connectivity. Now, we've got some dynamic stuff going on here as well. If I take a look at my config template, which is part of this plan, I have it here, and this is a Ruby on Rails example configuration template. It's got some key value pairs, like which database type are you using. I've chosen Postgres for this example. What's the username and password for the database. And you'll see we have some placeholders in here, which are going to be filled in at runtime when we run this initialization hook. So this gives us the ability to discover services on the fly, which I'll do in just a second. We also have a run hook, which defines how the application is run. And very simply, after some exports, we exec Unicorn, which is the application server bundled with Rails. Now, I mentioned earlier we can override configuration. We can do it in a number of different times. We can override, if I look here, we have a set of defaults. So these defaults, when we run our application, are pushed into configurations and pushed into the running process so that we can populate database names, usernames, and passwords. In production, my database password should probably not be quotes, should not be empty, right? It's not very secure. So when I run this in production, I'm going to want to supply a new database password. But this is a sensible set of defaults, which will then be pushed into the YAML file. I can also override those things. So when I come to run this, I can actually push in a database password, which is super secret and super secure, into the running application. So let's do it. We've got a plan, and we can build our application. And I will go ahead and do that for you now. So Habitat comes with what we call a studio. It's in the Mac world, it's a running Docker container, which it gives you a clean environment to build your application. So there's essentially nothing there. And it makes sure that when you build the application, it does have all the dependencies which the application needs. And I'm going to initiate a build of it now. So I'm in my directory where the plan is. I'm going to initiate the build. And what it does is it kicks off this process where it understands the plan, it grabs all of the dependencies, and starts to install the application according to that plan I just showed you. I also need a database, right? So I have my Ruby on Rails application package, which is getting built, but that, as we saw in the configuration, depends on a Postgres database. So we need to do that. The great thing is that if we take a look at the core plans, so these are core plans contributed by the Habitat community, both people who work for Chef and people who are outside of Chef, part of the open source community. We have a default plan for Postgres. And this has all of the information needed to install Postgres, download the package, configure, that kind of thing. So we can actually get a Habitat package, which is a Postgres database already. We don't have to worry about building it for our systems at all. So let's run that now. Thankfully, I don't have to do much of the typing. This Postgres and all Habitat packages are exportable as containers. So here I've actually got my ready exported Postgres database container ready to run. I'm going to pipe in some configuration stuff from the TOML file, which is overriding usernames and passwords and stuff. And I'm going to expose a port, which is 5432. And that's going to go away and run this Postgres database package. So if the screen comes back, you can see here, it's done some stuff, and auto vacuum launcher started says that our Postgres database is running, which is cool. I haven't had to do much work to get this environment ready, which is great for development environments because you can spin up a nice clean environment on the fly. It's still building the application here as well. And what happens at the end of it is you get a artifact file called a Habitat artifact. So the extension is .heart, and that is runnable by the Habitat command line. However, the Habitat command line only supports natively Linux environments. So to export my application, I have to either put it on a Linux host somewhere and run it there, or I can also export it as a Docker container. There are other export formats as well. So I can do that now as well. So it's built, right? So I could theoretically run this package I've got on any Linux host. But as I'm on my Mac, I can also export this. So we have a command line called Habitat, package export Docker, and then the name of my application, my name of my package, which is going to go away and actually build me a Docker image to then run. Just to show you the database YAML file again, because it's going to become very interesting very soon. So that's going away, and that's going to export my package is a Docker container. Now, for all Ruby on Rails applications, we have this database configuration file. And one of the key parts of Habitat at the runtime level is service discovery. So when I run, remember I've got a Postgres database running right now. When I run my application, I want to be able to find that Postgres database, but I don't know what the IP address is. I don't know when I enter a topology, a ring, where different bits and pieces are. So I need to be able to find that information, and it has a service discovery capability. So the Postgres database publishes itself as a Postgres database. We know it's a Postgres database because here it's called PostgreSQL default. So that's the name of the service which we want to discover. And remember, we could have a number of these running as well in a topology if we wanted to. And when I run the application, I can go and find that and join the ring. Now, to join an already existing Habitat ring or a Habitat topology, we need to know the IP address of one of the current running containers or applications in the ring. So as I'm in the Docker world right now, I can do a Docker PS. To see I've got a running container here called PostgreSQL, so I can go and grab the ID of this container, and I can say Docker, oops, I spelled Docker correctly, Docker inspect ID, and we can see we have an IP address, which is the sort of internal IP address of the Docker container running on this laptop. So I'm going to use that in a second, and hopefully my container is built. Successfully built. I spoke for enough time to build the container, right? So I now have on my system an exported package with this Docker container in it, which is awesome. So I can go ahead and run it now. And I have, rather than typing this big command line out, I've done it earlier just to save us all some time. So I'm going to run this container. And the E says set an environment variable. And I have a TOML file, which I showed you just earlier, which is the override. So we have our default configuration. When I run this, I'm going to pipe in some default overrides, which will update the configuration, but I don't have to rebuild the container to do that. And it will push these username and passwords into my running container. I'm going to expose the port so I can actually talk to my running application, the name of the container. And then we've got two Habitat-specific variables I'm piping in. So we've got peer, which is the IP address of our running Postgres container. And this could be the IP address of any other container running in this topology, right? They form a ring and a network of supervisors which all share information. And then I'm going to say bind database PostgreSQL default, which says, OK, once you've joined the ring, then go and find me my database called PostgreSQL default. And when it does that, remember in our configuration, we have this config, database name, database username, and passwords. So it goes and discovers everything which is tagged as being a PostgreSQL database. We may have more than one. It loops over those because we've had this if and each TOML syntax. If we have a database, it goes and puts in all the database credentials for our application dynamically. So we don't have to predefine the IP address of all of our databases or anything we're connecting to. It does it dynamically at runtime. And if anything disappears or anything goes away or we want to change anything, it will do it dynamically as well and update our configuration file. So what we want to see, which we have seen, is worker zero ready, which means our unicorn application server has a worker process ready to accept incoming connections. And I can tell you're all dying to see the actual running application. Apologies in advance for my poor UX. I'm a developer, not a UX person. So this is what it looks like, right? This is the running application running here, talking to a PostgreSQL database. We could spin up and spin down new instances as we see fit with this technology. And that's it. So Habitat allowed me to not have to worry about the ops side of DevOps, to define my application, define how it should be built and installed and packaged, build it into this package thing, export it as a container, run it, and talk to other containers, and free me up from some runtime concerns as well. The technology itself is open source, so if you're interested and want to play with it and learn more, habitat.sh is the website. We have friendly people at Chef around today who can talk in more detail to you about Habitat, answer any questions you've got. And thanks very much for listening. If there's any questions, I'm happy to take them.
Are there any questions? Nope, not yet.
Wow.
So Chef is here. If you have questions after, oh, well, we have one question.
Oh.
Hi.
Hey.
Question about configuration management. Imagine you run your application in different environments, like staging, production, and so on.
Yeah.
I might have missed that in your talk. How do you manage different configurations for different environments?
Yeah, it's a good point. So I was sort of theoretically running this as a production application, but in reality, what you'd want to go is through some delivery pipeline and check in different environments, as you said. So let me re-plug this in. I got too excited there and unplugged. So just to re-examine this. So this is an example configuration file, right? This is a Ruby on Rails YAML file with some config stuff. And I have, by default, a default configuration, and all this information gets pushed into that configuration file when the thing is spun up. But when I span up my container, which I'd exported, I also added some overrides for, now this is called daphneonline.toml. It's probably not the best name for it. What I'd really name it is staging.toml or test.toml or production.toml, which would have all the configuration information. Obviously, you might want to store these things encrypted as well, if they're passwords, so you can do that. So really, you'd have a different configuration file, or you can put it in environment variables directly if you want to, so it pipes into this hab Daphne Online or hab package name file. So you can override them at any point, but you're using the same application across a number of different environments with these overrides. Does that make sense? Cool, you're nodding, so. I think we've got one there.
What is the most advantage and the opposite to other configuration management tools, such as Ansible or Puppet? That's interesting for me.
So it's a good question. So this, I see this as being sort of orthogonal to traditional configuration management. So configuration management tools such as Ansible, Puppet, and Chef are, and I work for Chef, so I like Chef, right? I'm going to be a bit biased. They pay my bills. So configuration management tools are really good for infrastructure. So if we have an operating system which we need to secure and we need to maintain the integrity of that operating system, those tools are really, really powerful. And for maintaining compliance too. So compliance has a whole bit of its, Chef has a whole bit of its product which looks after the compliance to known industry benchmarks, so the CIS benchmarks. And this is more focused on the application. So it's really taking away the worry about infrastructure and focusing on the application itself. And also understanding that a lot of people are moving to this world where we're using microservices and containers. So it's about making the journey into microservices and containers a bit easier by doing things like dynamic configuration, like the runtime stuff, like the service discovery, like the ability to create containers from this thing. But traditional configuration management, such as Chef and others, isn't really dead because you still need to run these things somewhere. So typically you're going to run containers on some sort of host somewhere with Docker installed or Kubernetes or that kind of thing. So those hosts where you run these things still need to be secured and maintained to the right configuration. So I think this looks after the application side of things and the service side of things, and traditional configuration tools, management tools, look at more of the lower level down the stack, but it's still really important.
Okay,
Thanks for the question.
Thank you. If you're unfamiliar with Chef, definitely stop by their booth, and they're all happy to inform you about it.
We are.
Thanks.
Thank you.
All right.